There it is, Tomer. Thank you. Tomer, that looks perfect. Are we okay to begin?
Yes, let's kick it off.
Okay. Again, we'd like to thank everybody participating today. As I just mentioned, this is the first VPG Force Sensors webinar. We hope it's one of many to come in the future. Today, we're just going to be taking a few minutes to talk about our Edoc corrosion-proof coating. And before we do that, I just want to take a minute and introduce my two co-hosts, Mark McCombs and also Tal Rahav. Mark, if you could just take a minute to explain your background and your role, please.
Thanks, Rob. As noted, I am Mark McCombs. I am a segment sales manager for the medical for VPG. And as that type of segment, generally I handle load cells and force transducers in medical beds, mammography, renal systems, dialysis. Prior to my time of being a segment manager, I designed load cells for 15 years. So I have a mechanical background and I'm always available for application assistance.
Thank you, Mark. Tal?
Yeah, thank you, Rob. Thank you, Mark. I'm Tal Rahav. I'm the Director of Design and Development for the Force Sensors Division. I have over 30 years experience in design, and I will be assisting Rob and Mark today with the more technical issues of the system.
Tal, your line is very, very poor. Can you try and talk closer to the microphone, please?
Tal, did you hear Tomer? You were very faint. Are you close enough to the mic, please?
I am as close as I can be.
Oh, much better. Thank you. Okay. Thank you, Tal. I'm Rob Upright, OEM account manager with VPG Force Sensors. I've been in the industry about 37 years. In January, it's 19 years at VPG Force Sensors. I have primarily focused on the OEM business for the construction and the agricultural industries. A couple housekeeping items, as always, with all the webinars that many of us have participated, particularly over the past 3 years. As you know, when you logged on, this webinar is being recorded. We anticipate this webinar to be approximately 30 minutes today. Any questions that you have, and again, we welcome questions during the webinar, please enter them using the Q&A feature. We will try to answer some of these questions as we're going through the webinar, and then hopefully we can just do a recap at the very end of the webinar of all the questions, giving you answers. And for anything that we can't address today, we will definitely follow up with you. We will also have a few quick polls. We would appreciate if everybody could participate in the polls. The information that you get back to kind of helps us quantify who was able to participate and why today. For the first slide, Tomer, if you could advance one, please. Again, this particular webinar is on Edoc, which is VPG Force Sensors electrodeposited organic coating. It's a proprietary access that we developed approximately 15 years ago, and we have fine-tuned over the past 15 years. It's become very, very beneficial to use on a lot of OEM custom load cells that we have fabricated for those customers. And we've got to the point now where we want to expand this to all the load cells that VPG Force Sensor makes. Before we continue, I'd like to turn it over to Mark. Mark's just going to give a quick background on what a load cell is. Mark?
Thanks, Rob. You know, we do this every day, and I think we get used to what our products are. But for those that are not familiar, a load cell is an electromechanical device. We have a metal element, be it aluminum, alloy, or stainless steel. That's essentially the body of the load cell. And because we know the mechanics of the materials and the amount of material that's been removed from the load cell in the deflecting area, we can specifically know through calculation the amount that the load cell will deflect under a very specific load. So we've got this deflection that's happening under a load, and we need to convert it to a usable signal. So within the inside of the load cell at the deflecting area, we apply a network of strain gauges, commonly known as a Wheatstone bridge. And that's excited by generally a 10-volt regulated excitation. And as you apply a force to the end of the load cell or the center of the load cell, depending on the element design, you'll get a corresponding signal output. So generally speaking, it's a millivolt per volt analog, but we can certainly have an internal amplifier and have a 0 to 5 volt, 0 to 10 volt, 4 to 20, or more commonly now a CAN bus or an I2C output.
Thanks, Mark. Tomer, next slide, please. As mentioned, this has been in process for approximately 15 years. What drove it originally was just load cell coatings prior to this for VPG. Even using a stainless steel load cell, we had issues in the field, in the agricultural and the construction applications. Since then, we have processed and made over 500,000 load cells used particularly in these two markets. And what we'd like to do is expand that. So with this Edoc coating, we've done several different types of independent lab testing. The one that most of you on this call today are probably most concerned about is a 1,000-hour salt fog scratch test. We were successful in that. And you know, again, some people may be thinking, and we've had some people even prior to the call say, you know, why is it taking this long to come out with this? Well, when we looked at the very first Edoc unit 15 years ago, we've made a lot of improvements and iterations to where we feel we've perfected it now. And this, again, is why we want to offer this to all of our customers, whether they're custom OEM applications or the standard load cells that are in our catalog or on our website. Next slide, please, Tomer.
Just a minute.
Oh, Tal, go ahead.
Yes, I would like to interject here. Thank you, Rob. Regarding the 1,000-hour salt fog scratch test, I would like to emphasize that the 1,000 hours is an artificial stop. We could actually continue on. The parts after 1,000 hours looked like they were at the beginning of the test. So we figure they would go up at least another couple hundred hours. So this was just a methodical stop because we had to sometimes end the test just to elaborate on that. Thank you, Rob.
Thanks, Tal. Mark?
Well, these are a couple of applications that I think show how the Edoc coating system is extremely beneficial. If you know, those of you that are in this type of industry will notice we've got a very dusty, dirty, and potentially corrosive environment working with concrete batching. You've got a lot of chemical attack on the actual load cell. And if you look at the picture on the upper right-hand side, you'll see the amount of corrosion that's happening on the load cell. That's actually a stainless steel load cell. So everybody in the industry would like to think that stainless steel is the end all to be all for corrosion resistance. And in many cases it is, but where you're in an atmosphere or an application where there is alkali, other type of chemicals that can attack even stainless steel, that's where the Edoc really comes into play. That Edoc coating will guarantee, certainly guarantee the lifespan of the load cell and protect it from any type of environmental attack, chemical attack. And if you're using the load cell in a place where you can't visibly see it all the time, it's good to know that it's already protected and you don't need to worry about what's happening in the application as far as the load cell being affected by chemicals or contamination.
Thanks, Mark.
Thank you, Mark. I would like to add a little information here. As Mark informed, the unit here is actually a stainless steel unit, and It's common to think that stainless steel is corrosion proof, but it's not. You can see it's only corrosion resistant, and it's resistant up to a point that is very dependent on the surrounding environment, the material that's coming in contact with it. And alloy steel and more, stainless steel are very sensitive to chlorine, nitrites, sulfides, which can quickly and very strongly attack the stainless steel, where it will premature fail even faster than alloy steel under some conditions. So specifically in applications like this, like in the agricultural industry, where you have fertilizers that have sometimes all of these components combined, the Edoc is very effective. Thank you, Mark.
Thanks, Tom.
Thanks, Tal. Next slide, please. Now with Edoc, with VPG being able to offer Edoc on all of our load cells, we feel, again, this is a superior protection to anything that's on the market. It is a very cost-effective method. And as Mark just referenced in the prior slide, a lot of load cells are installed on pieces of equipment or in scales or in systems that they're not easy to get at. So if we work with you to develop a load cell and you decide to go with Edoc, we hope that, again, you have the confidence and it provides that, peace of mind that down the road, you're not worried about what the environment is doing to that load cell, that it will last. Next slide, please.
Well, thanks, Rob. Let's talk a little bit about load cells. Again, going back to where we were. And it's important to note that the 5 load cells that are shown here are just basic load cells that are in our standard catalog. We do many, many OEM load cells that are custom, specific to the application, and particularly for medical, agriculture. So certainly if you have an application and you don't see anything suitable in the catalog, so let us know. We'll be happy to work with you, as well as work with your engineering team to develop a load cell specific to your application. So if we start here first on the left, this is a 1022. It's a single point aluminum load cell. This is a load cell that's designed to be used, as the name indicates, as a single point. So you use a single load cell underneath a platform, a small platform like a postal scale, and they're mechanically compensated for off-center loading. So when you move that weight around on that plate within the tolerance specified, you won't see a deviation due to the moment load. The second one over, this is a model 182. It's the extensometer. This is really good in an application to explain how the Edoc works. The 182 is generally bolted to an axle case on earth moving equipment, tractors, that type of thing, where you're in the field, you're in an environment where that model 182 is right down in the dirt, salt, any type of corrosive environment that's coming out of the earth. So it'll certainly protect it throughout the lifespan of the load cell. And it's a very handy thing for safety, as well as generally monitoring the terrain that you may be on with the earth moving equipment or the tractor. The center is the S-type load cell. It's kind of a unique design. If you look at the center of the load cell, you'll see it's actually a beam, and the top part of the S and then the bottom part of the S are just a different way to hold and load that beam in the center of the load cell. So when you've got an Edoc coating on this, you can certainly use it in a hanging scale by itself, or you can gang them together in 3 or 4 units in a corrosive environment. A lot of these are used in mixing. So that Edoc coating, again, is essentially a peace of mind that you don't have to worry about what's happening to my load cell if I can't see it. The fourth one along is our model 1042. It's a low profile aluminum load cell, similar in use to the 1022. And then to the far right, we've got the 4310, which is an example of a shear beam load cell. Shear beam load cells are generally used in a platform scale. So say a 4x4 platform, they're mounted up underneath the platform, so they're really out of sight. So having the Edoc coating can protect that load cell for something that you can't see. If the environment is corrosive, dirty, dusty, again, it's a peace of mind that you don't have to worry about whether or not the load cell is being affected by its environment, because you can't always see it.
Hey, Tal, a quick question. Tomer, if you can go back to the slide. Tal, Mark was talking recently, and I'm not sure if I don't think we cover it directly here. When you have load cells like, on the far left, the 1022, or the fourth one in, the 1042, and you have threads, is there any concern about the impact of this coating on load cells that have threads that are used to install the load cell and mount the load cell?
Well, there is an effect on the class of the thread. However, we compensate for most of it in the machining, because the E-coat is a relatively thick coating, so you have to take into consideration the thickness of the coating. And of course, when you apply the bolts, they may remove some of the coating or affect it, but in general, it's like any other coating or any other paint that you use.
Got it. Thank you, Tal, for elaborating. Tomer, next slide, please. So as we've kind of mentioned, again, the development of this and to where we would like to go with our products today, it's the harshest and the most extreme environments. And typically, for those of you that are participating today, your colleagues and your companies and industries, we are, really focusing on marine applications, as construction and agricultural. This is very key to us. Livestock farming, which again is part of agricultural, that market, chemical industries, and then also too, Mark had mentioned earlier, which is his focus for the company, is even some medical applications. There are areas where, we don't think most medical applications may be inside, but it's still advantageous to have a superior coating on a product, depending upon that application in the medical industry. So this, again, could be extremely helpful. Next slide, please.
Rob, this is a pretty good graphic illustration of where that Edoc coating really comes into its own, especially in a farm application. It's dirty, it's dusty, there's fertilizer. As Tal noted, these are all things that the Edoc coating will make that load cell resistant to attack. Cows' urine is incredibly acidic and can really attack virtually all types of steel, including stainless. So that Edoc coating really extends the life of the load cell, making it essentially unaffected by any outside environment, so that the load cell can have the standard life as it's designed to. If we look to the bottom center, this is a good example of a load pin. So instead of just the pivoting pins, we offer load pins. Pins are designed to deflect just like a load cell, but they're inserted like a pin. And in this environment, you can monitor, make sure that you're not overloading the platform, make sure the center of gravity is correct, make sure there's no tipping happening by monitoring the amount of force that's happening from one pin to another. So it's very versatile. And a lot of these applications for the platform scales or the lift scales that are out in the weather, there are all kinds of weather, all kinds of temperatures. So again, the Edoc really comes into play. And on the right-hand side, we see two really good examples of how this Edoc coating is fantastic for use in load pins that are used in container cranes. When the container is lifted off of the container ship, or whether it's being loaded, there's a snag system can indicate whether or not the container may be contacting something, either on its way up, there's excessive force, or on the way down, there's a loss of weight. And you see on the bottom where these the container cranes themselves are right out over the ocean. So It's a very corrosive environment. And again, the Edoc gives you that extra level of security.
Thanks, Mark. So as we've referenced earlier, again, the equipment and the machinery that are, you're typically using load cells, and where we feel Edoc will be very beneficial in a lot of these applications. Again, replacing a stainless steel load cell, which we all know is, and I think Tal said it earlier, is very expensive, but then particularly being able to be used on aluminum and or alloy steel, to be able to use those metals in a very harsh environment. We feel this, again, is much better than just corrosion resistant that you typically see in aluminum or steel. And this, again, is going to be better than just plain stainless steel. As we saw in the earlier pictures of that load cell and the mount and the fertilizer application, you think stainless steel is going to last, but depending upon the specifics of that application, it may not always last. Next slide, please. Mark?
Well, to summarize what we've talked about, we've been providing this Edoc coating for 15 years, and the question is, well, why now? Well, it's something that we've been developing, and it's been refined to the point now that it's not really specific to customers that simply ask for it. We'd like to offer it so that everyone is aware. It's a fantastic opportunity to certainly make sure that the load cell lifespan is not affected by any type of environmental changes or acidic environment applications. I had an application where we had an aluminum beam that went underneath a drink mixer, and it was used for cruise ships. And we were getting these aluminum beams back. They were absolutely eaten, just absolutely attacked. There was some concern maybe that it was coming from the salt environment, but in the end, after we did a chemical analysis, we found that the real attacking that was happening on the aluminum was coming from the alkali in the drink mix. So sometimes there are things that are corrosive that you don't really think that they could be, but it depends on the material of the load cell. In this case, it was aluminum. So the Edoc coating solved that problem, and we certainly moved forward with that. Everybody was glad to see it. So Tal, can you expand a little bit about, again, the testing that we've done, and we've got 500,000 applications out there with these load cells and have not had a single one return due to failure of this Edoc coating, and the fact that it's not just a paint and it's not an epoxy, it's a proprietary coating.
Yes, I would like to dwell on the cost effectiveness. In many cases, we offer this as an alternative to stainless steel load cell. Unless you have an industry where the regulation mandates that you use stainless steel, like pharmaceutical or food industry, for all other applications, you most probably be more cost effective if you go with the Edoc rather than stainless steel. You'll get better corrosion protection and lower price. Now, the Edoc does not come for free, of course. There is a cost for the Edoc, but it's not as costly as converting the part from steel or from aluminum to stainless steel. In general, the addition of the cost is, I would say it would start around $10 and go up depending on the size of the part, the surface area, and of course the quantity. But in any case, the difference will be much less than moving to stainless steel.
Great.
Thank you.
So essentially what we would like to do, again, is making this Edoc protection available to all of our customers. We'd like to be viewed as a partner in development of custom OEM products, and certainly offer this if everybody feels as though it would make sure the load cell is not affected by the application or things that could happen during the application. So it's essentially just a way to make sure that you see that load cell have the ability to work its way all the way through its lifespan.
Thanks, Mark. We do have samples available, and we can provide samples if somebody is interested. It's just like when you're starting an application, you need a load cell to try out. So with the Edoc, we do have samples that could be available. For those of you that are on the line that have a current account manager, just contact your account manager or your customer service representative, and we can look into getting you samples. If there's anybody that is on the line that doesn't, right now have an account manager with VPG Force Sensors, when we're done with this webinar, Ileana, who has also been very instrumental in getting this webinar done at our facility in Israel, she's going to send an email out with a brief survey. We really hope that everybody can just take a couple minutes and complete that survey and send it back. And also in that email is her contact information. So if you have any questions, you can, just contact Ileana, and she'll make sure that the correct global individual gets it to.
Well, we do have some questions on the Q&A. If you can address them, please.
Tomer, can you mute yourself? Thank you, Tomer. There are a couple. I think everybody can look at the Q&A. There was an earlier question about any cleanliness concerns. And Mark is, again, multitasking. As he's doing the presentation, he's answering the questions. The answer to that is no. The coating can stand up to long-term exposure and is very effective when the load cell is not readily visible. Next question is, are there any load cell designs that Edoc would not be suitable on? Mark, are you answering that, or could you and Tal address? Actually, I guess Tal could address that.
Yes, I would like to address that. At the moment, we are not offering it on welded stainless steel, and currently on single points, we are still improving some aspects. So at the moment, the single points will not be available for samples, but they will be later on. But it will not be available for welded stainless steels. Other than that, we can apply it on any type of material, almost any design. But it's very important to stress that the coating is applied at the sensor element level before bonding. So it goes deep. All the surfaces of the part are covered, and it's not a process that can be applied on a finished good item. So these are the limitations.
Oh, we had a good question came in. I'd like to turn it over to you for a more specific answer. And the question is the coating more porous than typical stainless?
Generally, no. It's a continuous organic coating, and it's more resistant to pitting under most materials. We will issue, or we will publish a material compatibility chart later on, just to verify that if there are some materials that will not work well with the E-coat. I would say, as any other coating, the Edoc and any other, if it's epoxy or even any electrolytic coating. Every type of coating has its limitations, so we
Right.
will publish this later on.
Thanks, Tal. Tal, one of the other questions is, does Edoc impact any of the basic load cell characteristics, full scale output, creep, et cetera?
No, it has no effect unless you go down to the very ultra low capacities where we will not offer it. There is no impact on the performance of the load cell.
Okay. Another question, Tal, I know we're reverting to you a lot. Are there any environments or products that are a contamination concern?
As I mentioned, it will not be approved, I assume, for pharmaceutical and food processing industries.
Right. Okay. And actually, one more, Tal, to what industry standards for corrosion does Edoc meet?
Well, the salt fog test is done according to an ASTM test. So it's a standard salt fog test, just like any other test that salt fog.
Okay. Mark, I know you're answering another question. I think we've covered them all.
I think we have, I think we're caught up. We do have one question, is that will the Edoc be offered for mount accessories like for the ASC2? I think we covered that.
Right.
We certainly can offer that.
Yep.
Yes, the Edoc can be applied to any metal, and so any of our accessories are also candidates to receive the Edoc if necessary.
Okay. And this question is, I think, pretty important. Tal, has the Edoc process been tested to any like US FDA certification, or is there anything that like that that's applicable?
No, it's not been tested to FDA specifications, and at the moment we don't have a plan to do that. As I mentioned, food industry and pharmaceuticals at the moment, I do not see them approving this sensing coating.
Okay.
And the
basically because there will be somewhere some material may be removed and go into the product. This is the major concern in the area.
So that would be like any coating, Tal, right? I mean, I think
like
any coating would fall under that.
Right.
Correct.
Okay. Is there a way, Tal, to define the thickness of the coating, or is it nominal within drawing tolerance?
It's a nominal thickness. We keep the thickness as part of the proprietary information. As you mentioned in the beginning, it's a multi-layer coating, so the thickness is divided into several thicknesses. So we're not specifying the exact thickness of each layer.
Gotcha. Good. Mark, I kind of jumping back in between the open and the answer. I think that's all the questions.
We've got one more, and that is,
yep.
Are there any changes in the packaging to indicate whether or not a load cell inside a box, for instance, has the Edoc coating? I suppose for the catalog industry, if you have an OEM load cell and the Edoc is worked into the specification, then they would certainly come that way, right? So if we add the Edoc coating, we can certainly add a labeling to the box to indicate that they are coated, certainly.
Okay.
That,
Good.
that will be expressed in the item number.
Correct. Yeah, I was thinking of that. Yeah, great questions. Thank you, everybody. That looks,
I think we're caught up.
yeah, Mark, I said, I was going back between the open and the answered. I think we're good.
Frantically trying to multitask with two hands that don't
Yeah.
communicate for typing. So
Right. All right, Mark, anything else to add? I think we've covered every aspect of it, but anything else?
in closing comments, again, this is a coating that can certainly be applied to any load cell, and I would encourage anyone with a custom application, by all means, reach out to VPG. We'll assist you in the design and make sure you get exactly what you need. If you need a load cell, you might as well get exactly what you want from the start and not have to modify your machinery to fit. We'll make the load cell fit your machinery.
Thank you. Tal, any last comments?
I just want to say that we already have a few standard items, mostly in the S-type and the shear beam that are already defined, so it will be easier to start there for people who want just to evaluate.
Got it. Thank you very much, Tal. Both Mark and Tal, thank you for everything today, particularly from the technical side. I think that's a lot of the people we have on the call today. We do, again, as we said in the beginning, we know everybody's busy. We sincerely appreciate everybody taking time today to listen and to participate. Again, just a bunch of great questions here at the end. And Tomer, because you are controlling, anything else before we let everybody go?
No, I think we're good. Thank you all.
Good. Thank you, everybody. Have a good day, good mornings, and a good afternoons. We'll talk to everybody soon.
Thank you, Rob.
Thank you all.
Thanks, Tal. Thanks, Rob.
Bye.